This time we're going to use the graphing calculator to check an inequality. In fact, we're going to check two. This came right from the EDUCO tutorial, one of the examples. The example is shown here. 5x is less than 3 times the quantity x minus 4 plus 7. I followed the solution, and the solution given was x was less than a negative 2.5. And it is shown graphed here with an open circle at negative 2.5 and the points to the left of that circle shaded. All right, let's get the calculator and see how we would check this. We have to check two things here. We want to check that we've got the circle in the right place and that we've shaded the right side of it, not the wrong side. Okay? So we want first again to also check and see that we've got our table set up correctly. So I'm going to push the second key and the window key to get the table set up, which is above window, and look down across from independent to see that ask is highlighted. And I already set it up on another problem, so it will stay that way unless I change it. So it is set up. All right, so then we will go to the y equal key and clear out anything that's in there. And we're going to put the left side of the inequality as y1 and the right side of the inequality as y2. And we'll put 5x. Again, the x key, the x shortcut key looks like xt theta n, and it is right next to the alpha key right here. All right, so I'll hit that, and you can only use x, and that's all I have on the left side of the inequality symbol. On the right side of it, I'm going to put that for y2. I have 3 open parentheses x minus 4 close parentheses plus 7. All right, so I've got the left and right side entered, and now I'm going to table, which is hit second and graph because it's above the graph. Now there's already something in there from another problem, so I'm going to hit delete to get rid of it. All right, and now I'm going to enter 2.5, and that is where the circle is. And notice that is not part of our solution. What I'm looking for is, will it make these two things equal? Because that is where your endpoint should be, where they're equal. On one side of it, the left will be less than the right. On the other side, the left will be greater than the right. So it sort of breaks that point should break it into the less than side and the greater than side and the place where it's equal. So I'm going to enter negative 2.5 and see what happens. And it gives me a negative 12.5 on both sides. So I'm going to put a table over here to show my check. And I'm going to put in that table for an x value. Okay, back to the virtual. Hang on. All right. For my x value, I'll put negative 2.5. In the left side, I got negative 12.5, and the right side I got negative 12.5, and it did make both sides equal. Okay, that's the right side, and so that does something I wanted it to do, so I'll put a check mark there for that. Now I've got to take one of the solutions that's over here, and that will not make it equal, but it should make the left side less than the right side. So let's put any point from that. Negative 5 would be a good one. So I'm going to hit negative 5, enter, and see what I get. I get negative 25 for the left side and negative 20 for the right side. So I'm going to go back over to my graph and put negative 5 here. Negative 25 was what I got on the left side. and negative 20 was what I got on the right side. And I look back at the equation and see if it makes a true statement. The left side is less than the right side. See if it makes that true, and it does. So I've checked to see that the solution works, and it does. Now we're going to do a three-part inequality and check it. I took this one also from the examples in the tutorial. The problem has in the middle 1 minus 2x. On the left side is between negative 3 and 6. We have an inequality that says less than or equal to on the left, and an inequality that says less than or equal to on the right. The solution that we got was that x was between negative 2.5 and 2, with equality allowed in both of them. And so we can see that we have a solid circle here at negative 2.5 and another solid circle at 2, and all the points in between showing as solutions. And the endpoints here should make it equal to one of these original boundaries. That's what we're looking for in this check. This check is a little bit easier even than this inequality that we just saw. All right, let's get the calculator up here and go to the y equal key, clear out what's in there. And the only expression that we really need to enter here is the expression in the middle, because we have number boundaries on both sides of it. So let's enter 1 minus 2x. And then we will go to the table feature by hitting second graph. And we see there's some numbers already in there. So let's clear them out. Up, I hit clear. Now if I hit delete now, it's not going to work. So I just juggle my arrows a little bit here, go back and hit delete. And hit delete again, and I'm fine. Okay. And then let's, what we're going to do is just enter one of these, and we should get one of these bounds, and enter the other, and it should give us the other one. And then that would mean that between these two numbers will fall between the 1 minus 2x will fall between these two numbers. So let's see what happens. When we enter one of these numbers, okay, we're going to see what 1 minus 2x is equal to. Okay, so let's first enter negative 2.5. And hit enter, and we see we get 6. All right, we want to put this into a table, so let's bring a table over here. Okay, and just put in there that negative 2.5 for x gave us the boundary point, gave us the original bound of 6. So if we put a negative 2.5 in as the for x here, and calculate 1 minus 2 times it, we get exactly equal to 6. And then we'll just take the other value. Let's get the calculator back here. And this time we'll put the other bound on the solution, which was 2. And we are probably expecting to get a negative 3. And we certainly do get it. So when we put 2 in, we get a negative 3. And so we've checked it. That's all you need to do to check. You don't need to check anything in between because you've bounded it on both sides and gotten these bounds. All right, and that's all you need to do there.